Let's talk about standard streams and redirecting them in this video. So, every process in Linux, as soon as it's started, it's supplied with three files. These are called the standard input file, the standard output file, and the standard error file of a process. The standard input is the file that the process is reading its input from. The standard output is the file that the process is writing its output to. And standard error is the file that, in case an error happens with the execution of the process, then logging about this error is dumped to. Each of these files are associated with a file descriptor. In general, this is the style in Linux. The file descriptors for these three files are standard. The standard input has the file descriptor of 0, the standard output has the file descriptor of 1, and the standard error has the file descriptor of 2. So if a process wants to reach or access to its standard input, it uses the number 0 to address to this file. It uses the number 1 to reach the standard output file, and it uses the address 2 to reach the standard error file. Now, if additionally this process needs another file, for example, wants to open up another file to read or write to, then these other files also get file descriptors, but they start from 3. So the first 3 file descriptors starting from 0 are already allocated to the standard input, output, and error, which are also called the standard streams. By default, the standard input, standard output, and standard error of a process are defined, and they are related to our text terminal. So the standard input, also abbreviated as stdin of a process, is by default the keyboard. So each process by default is arranged to read from our keyboard. And the standard output and the standard error of a process are the same, and they are both our display. So for example, here in the terminal, if I give the command ls, then it's going to print an output somewhere. Okay, this is an empty one, so instead let me do an echo. The echo command writes what it gets as an input to its output, and this output, as you see, has been written to our shell window. So this shell that we can read, we can visually see, is the standard output for this echo process. Similarly, for example, the process cat. What cat does without any arguments is read something from the standard input. My commands wait until I press the enter, and after enter echo the exact same thing in its standard output. So here I'm entering from my keyboard, and my bash is also showing these in the terminal window, that's why I'm seeing it twice. But with enter I send it to cat, and cat is immediately duplicating its input in its standard output, which is the terminal window, until I cut it. If I, for example, write a command wrongly, so instead of lsis, lsss, then this is an error. So I receive an error. This error is also written in this terminal window, because this is also the standard error file. So this writing is actually not written to the standard output, but it is written to the standard error. And because my standard error and my standard output, they are both my display, then I can see it both at the same place, but they're actually written to through the different file descriptors. There is some supplementary material about this on Moodle page. It's a wiki page actually called "Everything is a File." So the Linux system more or less abstracts, well, maybe always abstracts everything as a file to make things easier for us. This includes devices like the keyboard. The keyboard is also treated as if it's a file, so it's easier for us to write our processes and scripts. We don't have to think about the exact dynamics of the keyboard, how to read from the keyboard, how does the keyboard device works, but Linux just wraps it up as if it's a file, and the process reads from keyboard as if it's reading from a file. The same is with the output, so the process doesn't have to think about how to print everything on the screen, but it just behaves as if it's printing to a file, that is file number 1 or 2, and then we see this on our Windows screen thanks to the mechanics that is provided by the operating system. So, reading from the keyboard and writing on the display is the default behavior of the program. But these standard streams can be redirected. We have seen parts of this redirection already in the commands that we have been using for some other things. So, for example, if I give this command, then the output is presented to me in the display. But I can redirect this output using this greater than sign to, for example, say a file. So now I didn't see an output here in my terminal because my output was redirected to this file. This file1.txt has replaced the standard output for this process. If I check the contents of file1.txt, then I will see that this output has been written into this file instead of my terminal. Similarly, I can redirect my input. For example, the cat by default, as we have talked about, it reads my input from my keyboard and then it duplicates the output here in the output stream. But I can redirect my input using this less than sign, and for example, I can tell cat to go and read its input from this file1.txt. In this case, it reads this file1.txt and then duplicates its what it read exactly in the output, which was my terminal here. This is completely the same with this notation, so not using any arrows but just giving an argument to cat. This is because of how cat is designed, so it's one of its most common usages is to check the contents of the file, but in general this notation is now what we need to learn about, because this can be useful for other commands as well. So this is otherwise completely the same behavior. We can do this redirection in the input and output, say at the same time. So for example, I can try to make a file1 copy like this. Now I don't see any output because I have taken the input from file1.txt and I have redirected the output of the cat to file1 copy.txt. So if I cat file1 copy.txt, I can see that the output has been redirected to here. In all the cases that I'm using cat just to check the contents of the file, of course my output is still the standard output, so I'm seeing the contents here in the terminal. We can, for example, also use cat to write multiple files, or so as to say combine them. This is a very useful usage of cat, so it's good to keep in mind. So if I have, for example, 3 files like this, it is possible to read from all the files and combine the output in one single file, for example, in which becomes the concatenation of first the contents of this file, which was this line, then the contents of this file, which was this line, and the contents of this file, which was this line. Also, I'm able to change the positions of these two input and output files, as long as it is consistent with the place of this arrow. So the input redirection is always followed by the name of the input file, and output redirection is always followed by the name of the output file. So for example, I can do cat to the file 1 copy number 2 by taking your input from file 1.txt, which is exactly the same thing. So the important thing is that you keep this input and this output as a group and move them together. Otherwise, it doesn't matter where I exactly use these arrows. So for example, if I want to read the contents of this file again, but I give this command wrong. I write cat t instead of just a cat, and this is an error. So if I have previously redirected the output of this command to output.txt, then what would happen? Can you guess what's going to happen now? Okay, I still see this here in my terminal. That is because this line has been written to the standard error file and not the output file, whereas here I was redirecting the output file. Since output file has been empty because this is an error, so this command didn't create any output for me. So if I check the output.txt, I will see nothing. But if I was, for example, doing this, instead of redirecting the output using, well, okay, remember that the standard output is 1 and standard error is 2. 0 and 1 can be omitted, but if I want to distinguish standard error, now I will put a 2 here, which denotes the file descriptor of standard error. So if I was, for example, redirecting the standard error instead, then I wouldn't see anything. So getting standard error, here the error line has been written to this file due to this redirection. It is completely possible, for example, to redirect both the output of a command and the error of a command, which may actually be quite useful. For example, if your command is processing a lot of output you don't want to see here in the terminal, is confusing you, but you also want to catch if it is creating an input, so it's completely okay to run this command, and then we can go and check both files. Okay, it didn't create any output. Then we check the error. Yes, then it has created some error, that's why we didn't get any output. And if the command was correct, then checking the output, we see that the command was successful and has produced some output in the output file. And then checking the error just in case, for example, we see that the process ended without giving any errors, so it was running okay. So it's completely okay to combine this redirection of output, error and input as you like, and their exact places doesn't matter. It's just the arrow sign, basically it affects the file name that's coming after it, so you can shift them around. There is one thing that you must always keep in mind with outputting this with this outputting command. It's basically, if I write something to a file by redirecting my output, this overwrites the previous contents in the file. So if there was anything in the file previously, it is deleted and my new contents are written to the file. If I want instead to keep the contents of the previous contents of the file and just, for example, add to it or append, as we say, to it, then there is this other notation, the two greater signs, which basically means append to this file. And now I can check my file and I see that new contents had been added at the very end of the file. It's also possible if, for example, I want to now let's use the cat example again. If I want to redirect my output to one file and also put my error in the same file. For this, I will first use the error redirection, and then I'm going to merge this stream with the first stream. So the second stream, the error, is going to be redirected and merged with the first stream, which is the output, which has been already redirected to this file. So, for example, if I do this and then I check all outputs, then this will have the output here. But if the command was erroneous, or maybe for example something that the cat won't be able to find, then if I check all outputs, this will also have the error in it because it has been redirected in the same place. Also note that the previous contents of the file has been deleted again because I have been using this deleting kind of redirection here. So in general, command and file redirects my output of the command to the file. Command and less than sign reads the input from file into the command. This is the appending output, so it won't delete the contents of file. This is for redirecting your error, and well, it ampersand. So this kind of, for example, using number A here and B here is merging the stream A, this can be 0, 1 or 2, with the stream B, which can again be 0 or 1 or 2. It's also possible, for example, that you are not interested in the output of a command. Maybe it's printing a lot of debugging strings that you are not interested in at some point, or for any reason. Maybe you are compiling a program and you are not interested with the detailed line by line output of the compiler. In that case, you can discard the output and the error of your process. For discarding things, there is this file under dev, which is short for devices in the Unix directory tree, and under it null, which is the null device. The null device is again abstracted as a file, but it's basically it basically doesn't exist. So anything you send to this dev null is just discarded by the system. So for example, I have my ls, and if I redirect my output to dev null, then I won't be able to see anything and it won't be recorded anywhere. So this is just discarded by the system. It's also possible to redirect the error, for example, or both the error and the output to dev null, and this will also discard the error for me. So this is how we redirect the standard streams to files and from files. But sometimes we don't want to exactly have a file to read or write to. We may want to, so as to say, chain commands or processes to one another. In this case, for example, instead of the program 1 or process 1 reading from the keyboard and then writing it here, and then process 2 reading from the keyboard again and writing it here, we may want to chain it so that process 1 reads from the keyboard and its output is connected to the input of the process 2, and process 2 reads from process 1, and instead of writing here on the display, it writes its output to another process, and this process reads from process 2, and then finally say writes its output on the display. We do this using pipes, which we have been seeing especially with grep. A pipe is donated like this, with this vertical line symbol. It is used to create a, so as to say, pipeline in the Linux system. So for example, when we were doing process and grep to say, maybe I can search for the process command. What we are doing here, normally this process was going to put its all output to the screen if I use this like this, but instead if I grep it, I'm channeling its output to the grep process, which is going to search for this substring and print only matching lines for me. So these are the lines that include the string PS in it. Well, somewhere it's a short string, so it's occurring a lot here. Or for example, if I ls and then I try to grep for 1, so normally ls gives me all this output, but now it is all that output is not printed in the screen because it's well, the standard output of this ls is now connected to the standard input of this grep, so the standard output is not written to the terminal, but instead it's passed to grep, which grep filters this coming input for the string of 1, and it only prints the names that has 1 in it. This kind of pipe notation is used a lot in Linux, and we are going to be using it as well. Basically, you can chain multiple commands to each other. So for example, I can have the commands of ls and then grep them for txt files and then grep them for 2, for example. So this is going to give me only the strings that have both of these filters. Or for example, I can ls and then I can cat and I can grep for txt. So cat basically takes something from its standard input and writes it to its standard output. So here it's like a, well, it doesn't have a special purpose, but yeah, it could have been used in other cases. So the difference of pipes here from the redirections using these arrow signs is that the pipe doesn't need a file to be written. It just creates the pipeline by immediately connecting the output of one process to the input of another one. So this is it for the redirections and the pipes. We will be using these a lot in this week's videos, so hopefully you will have a working understanding of them by the end of this week.